So let's do the second part. The second part is to find a missing angle. So once you have your calculator in degree mode, we should not have any issues to calculate the missing angle. In the diagram now, we want to calculate the size of angle x to the nearest degree. So angle x is this guy up here, right? Right here, right? And notice it's not in the triangle that we just worked with. So some of the things that we need to pay attention to whenever we're dealing with geometry problems, not always would our question have to be like a heavy set of trigs. Sometimes it could just be trigs with like a little bit of your basic geometry rules. But in this case, we have to use a trig ratio to find x, because we can't apply any geometry rules here to find the missing value. All right. Now, if I have to find the angle x, I need to pay attention to my triangle and the information that I'm given. Now, in this triangle, I don't know the hypotenuse, right? So first of all, this is also a right angle triangle. How do I know it's also a right angle triangle? Because the line QS is perpendicular to PR. So both sides would have 90-degree angles, not just one side, both sides. Next, the side that we're given is 9 centimeters. We just worked out the length of QS, right? We got the length of QS to be 10 centimeters. So we also know this information. Now, when we want to work out a missing angle in a triangle, and it's a right angle triangle, what we have to use is one of our trig ratios that these two sides could work together, but also we still have to pay attention to how those sides are related to the angle that we want to find. So in other words, right? Yeah, sure, we didn't have the hypotenuse, so we don't need to worry about ratios that involve the hypotenuse. But we still need to figure out which one is the opposite side, which one is the adjacent side. And the reason for that is because this time, we're not dealing with the 30-degree angle again, we're dealing with angle x. And when we look at a triangle SQR from angle x, what we notice is that the side 9 centimeters is opposite to this angle. And the 10 centimeter side would now be the adjacent side. All right. So this is the reason why, like I was saying, that perspective is very important. Because if we were to just go straight to town on trying to find a trig ratio, we would be thinking in our minds that the 10 centimeter side is still the opposite side, right? But notice this time, the angle x is adjacent to the 10 centimeter side, and it is opposite to the 9 centimeter side. So once we could figure that much out, we could figure out which trig ratio we're going to use. And like I mentioned before, because they did not give us the hypotenuse, we don't need to worry about a ratio that involves hypotenuse. So which ratio of the 3 ratios that we have here, which one does not have hypotenuse in it? Anybody? So you have 3 ratios and a 33% chance of guessing it correct. But if you paid attention to a lot of the things that we discussed just now, which ratio does not have the hypotenuse in it? So we have sine, which is opposite on hypotenuse, cosine, which is adjacent on hypotenuse, tangent, which is opposite on adjacent. Which of those 3 ratios does not have the hypotenuse in it? There we go, tan, right? So we're going to work with our tangent ratio, right? Tan x is what we're going to start off by writing, because we want to find the missing angle x. So our working is going to look something like this. We're going to write tan x is equal to the opposite over the adjacent. And like I said, it makes all the difference when you have to work this out, because tan is equal to strength of U raised over skin tolerance. sense. Indeed, it makes sense too, what you're saying. It makes sense. All right. So tangent, the opposite side in this case is the 9 centimeter side, which is SR. So we're going to put tan X is equal to 9 centimeters. Adjacent is 10 centimeters. All right. Now, if we didn't make that distinction between which one's opposite and adjacent, we would have the ratio upside down and we would get the wrong answer. Because these things all make a difference when it comes to trigonometry. All right. So that's why you have to make sure that you identify which side is opposite, which one is adjacent, which one is hypotenuse, and you use your ratios appropriately. All right. So from here, if I want to solve for X, remember I said X is an angle. So you're going to go to your calculator and let me just simplify this, right? So I don't necessarily need to work this out to be a decimal, right? I could actually tell you to enter this straight into your calculator. I've talked about using your fraction button before, and you can also just enter it as a division. But let's work with a decimal. It makes your life a little easier when you have to type. All right. So you're going to go to your calculator. And if we want to get a missing angle, we're going to use what we call the inverse trig functions. So the trig functions, as they are, they give us the ratios of the sides. But if I want to get a missing angle, I'm going to use my inverse trig function. So in order for me to get my inverse trig function on a calculator, I'm going to use my second function button. So the first thing is locate tan on your scientific calculator. And once you locate where tan is, you're going to look for your second function button now. All right, so you don't press the tan, you're just pressing second function first, then you press tan. So you press second function and tan, and now your display should have tan with a -1 to the top. So that's tan inverse. All right. Again, trig functions. Notice I keep saying the word, I say the word function, right? Because that's essentially what this is. The trig ratios are functions of the angles, and this is the reason why we have that inverse function. So that's why when you have to find X, you're not going to divide by tan. Okay, you're not going to multiply by anything. You have to understand that this is a function. So if I have to find that value X, I'm having the inverse function, right? I'm using the inverse function. So when you have tan inverse on your display, type 0.9 and press equal, and you should get an answer. All right, so let's work it out. Because also keep in mind, it's set to the nearest degree. Okay, so anybody want to share with me what answer they got? For tan inverse of 0.9. Anybody want to share with me what they got for their answer? So when you went to your calculator and you entered tan inverse of 0.9, what did you get? And I want to hear the answers because that way I'll be able to tell you if you're working with your calculator in the correct mode as well, right? So if you have a scientific calculator nearby, very good. Joanna got 41.988. So and actually like that she went to 3 decimal places, right? So one of the things that I want to highlight, so our exact value would have been 41.98724, I believe, right? Let me just double check. Yeah. 41.98721, my mistake. So I'm going to write this entire thing. Eight, 7, 2, 1. Okay. Now, I want to highlight this. So when we did the free past paper session, and even at the beginning of last semester when we had started classes, I talked about one of the reasons why I felt it was important to look at this foundation. So you notice in here now with your trigonometry, this is something that basically is an application of something you would have picked up before, rounding off. We want to make sure we know how to round off properly. right? And I want to make sure that everybody remembers how to round off, not just whole numbers, but also decimals. So let's pay close attention to that when we're doing the rounding off. Thankfully for this question, it asks for the nearest degree, which means we don't need to stress too much on the decimal values, right? But just for that bit of reinforcement, if we want to round off in, this case, let's say to 3 decimal places, we'll pay attention to the 4th decimal place. And in this case, because the 4th decimal place is less than 5, our answer would be 41.987 if we wrote it corrected 3 decimal places, all right? So if we want to get it to the nearest degree now, basically what they're asking us to do is round off to whole numbers, all right? So 41.987, what would we round that off to the nearest degree to be? What would we get? Y'all look at the answer Joanna has in the chat. She already put it there for you all. I wrote it on the slide. Y'all tell me, round it off. All right, so Jahim has an answer. Jahim is saying 42. If you agree with Jahim, let me know. You all agree with him? Nearest degree, 41.987 to the nearest degree is 42. You all agree with him? All right, so you're saying 42. Joanna agrees. Very good, Randy. What is the monster telling you? What is the monster telling you? Is it 42? Huh. The monster is not permitting him to type. All right, so the answer is 42 for everybody, right? Nearest degree, the answer is 42, so we're good to go. Now, like I said, very, very, very monster knocking cool. Clearly, right? The reason why, like I was saying, all those basic little foundational things, we want to make sure we get it down on point, simply because in a question like this, let's just look at the mark allocation for habits, right? Right, this entire question is 4 marks. Oh, your type was typing. I say 40 though. Okay. So this question is with 4 marks, right? So each part per would have been 2 marks. But in a question like where they said to state your answer to the nearest degree, one of those marks would be allocated for you writing your answer to the correct degree of accuracy. And if you fail to write your answer to the correct degree of accuracy, you're going to lose that mark. So while you might think, oh, it's just a mark, I'm going to make it up somewhere else, think about it. If there are questions that you can do to the best of your ability to guarantee yourself as many marks as possible, try not to lose your marks on basic things, like just losing a mark because you can't round off, right? So always pay attention to the degree of accuracy that they tell you. So if they tell you nearest degree, you write your answer for your angles to the nearest degree. If they say 1 decimal place, you write it to 1 decimal place. If they say 3 significant figures, which I know usually is the chaotic part of rounding off, you write your answer to 3 significant figures. And I've mentioned it before, especially for questions on trigs, when you get into your section 2 part of your paper, there, if you get any inexact values, by default, write your answers to 3 significant figures. Okay? If ever you have a problem that you have to work out something, you get an inexact value, write that inexact value correct to 3 significant figures. Okay? So this question, like I said, is with 4 marks. This is what it looks like. This is what you would have done. And once you have your calculators in the correct mode, angles would not be an issue for you. All right. Now,